So welcome to this latest video on 162 Math, and in this video we'll be going over some past GCSE exam questions related to histograms. Now as always, I'll include a copy of the questions that we go through in this video in a link in the description, and I'll also include lessons that are connected to this particular topic that go through everything in much more detail. Now before we get started working through some past exam questions relating to histograms, let's just have a quick overview over what it is you need to revise when revising histograms. Now the first thing is you need to know the difference between a histogram and a bar chart. Now a histogram is classed as a higher level statistical diagram, whereas a bar chart is pretty basic. You've probably done a bar chart back in primary school. Now the difference between a histogram and a bar chart is basically the types of data and how to read the chart. Now in a bar chart, that tends to be more for discrete data, where you've got worded data or particular numbers that can only take certain values. So for example, whole numbers or 0.5 a number, but it can't be anything in between. So it's what we call discrete data. So a bar chart is when you've got discrete data. So in other words, or quantitative data. So again, topics or genres that can only be words or certain numbers, and also where the height of a bar is proportional to the frequency. Now where a histogram comes in is when you've got continuous data, so it can be numbers within any data range, and it's basically also when you've got numerical data, or in other words group data, and also where the area of the bar is proportional to the frequency. So in a histogram, it's not how tall the bar is, it's basically the area of that rectangle that determines the frequency. So the bar with the biggest area is going to be the one with the biggest frequency. Whereas with a bar chart, it's a case of which one's taller is the one that's got the biggest frequency. Now the next thing you then need to know is how to work out the frequency density and how to complete a table. Now in terms of frequency density, well, frequency density is equal to the frequency of the group divided by the class width. Now the class width is always the upper bound, take away the lower bound, ignore the inequalities, don't worry about the decimals, just go straight into upper bound, take away lower bound, work it out, and that's your class width. Now when drawing a histogram, you need to make sure that you've got your x values going, or your group data going along the bottom, along the x-axis, and you're plotting vertically the frequency density. So make sure you're not making the silly mistake, or the common mistake that students make, is by plotting it against the frequency. So that kind of leads us into drawing a histogram. The next thing, which is then starts going into more higher level of the higher tier, is basically working with reverse questions. So this is when you're given a histogram and you need to work backwards to work out what the original frequencies are. Now as we mentioned, that in a histogram the area of the bar is the frequency. So what you need to do to work out the frequency is work out the area of the bar, but also know that the frequency is equal to the frequency density multiplied by the class width. In other words, it's the area of the bar. From that, you then can get asked questions to find particular frequencies, less than or more than. So for example, from a histogram, they may ask you, find out how many are less than 13.6, in which then 13.6 falls within a group, and you then need to work out the area to the left for less than, or the area to the right of that mark to work out more than values. And again, this will be covered, if not in this topic test, in the more advanced topic test that we do on histograms. Then moving on to grade 8, you then need to be able to find the median and find the lower quartile, which again is covered in a separate lesson which focuses on this particular aspect, because it can get quite fiddly, but it's also definitely covered on this topic test in the latter questions. Now a little reminder that if any of these things are a bit hazy to you, or you're not sure about them, I will include lesson links that go over all of these things in greater detail, and I strongly recommend you check them out before watching this video, continuing watching this video as we go through some exam questions. Now, a little reminder before we get started working through these questions that a copy of the questions that we go through in this video are available for you to download and have an attempt at before watching through this video so you can see what you know. All you need to do is just simply click on the link in the description. So looking at question 1, it says here is some information about the masses of m kilograms of people, and the question is asking us to draw a histogram to represent the information. So for this, what we need to do first is add 2 additional columns to this table. So I've got class width and I've got frequency density. Now sometimes students will not do the class width because they feel as if they can do that in their head, but you actually get a mark in as working out for actually calculating the class width. Now maybe not for this question because it's only worth 3 marks, but for bigger mark questions you may get a mark for class width, so always try and include it. So again, working out the class width, it's basically the upper bound take away the lower bound. So this first one's going to have a class width of 10, next one is 10, next one is 10, and the next one is 10. Then I need to work out the frequency density. Now the frequency density is equal to the frequency divided by the class width. So I'm just dividing these 2 numbers and then working it out. So 6 divided by 10 is 0.6, 19 divided by 10 is 1.9, 24 divided by 10 is 2.4, and 21 divided by 10 is 2.1. So the next thing I've then got to do now is plot my histogram. So again, I'm plotting this first column on the x-axis and the frequency density on the y-axis, or the horizontal and vertical axis I should really say. So these are the values that I'm plotting. So then if I just zoom out so I can see everything all on the screen. Apologies if this is going to prove to be a little bit small on yours. And then all I then need to do is plot those values. And if you've done it correctly, you should end up with something that looks like this. Now in terms of the height of those bars, so this one is at 0.6, this one is at 1.9, this one is at 2.4, and this one is at 2.1. Make sure you're reading these scales carefully. So for example, every little 2 boxes represents 0.1. And again, make sure you're plotting it correctly, as in this one we're going from 45, 55, 65, 75 and 85. So again, axes not really that helpful on this particular graph, but again definitely achievable and manageable. Then moving on to question 2, so let's just zoom in so we can see it on the screen. So again, very similar question but just different context. So it says the depth of d centimeters of a reservoir is measured daily throughout July, and it says draw a histogram to represent the information. So again, I'm going to create my class width and then my frequency density column. So this one's going to be 5, 5, 10 and 5. So typically with a histogram this should really have different class widths, and with this one we actually have got a different class width even though there's only one, and then it's just a case of filling in the numbers. So I've got to do 2 divided by 5, 5 divided by 5, 14 divided by 10 and 10 divided by 5. So here I get 0.6, I get I get 0.4, apologies, so 0.4, I'm getting 1, I'm getting 1.4 and I'm getting 2. So then all that's left for me to do is plot the first column against the frequency density. So if I move to the graph, the axes are already drawn for, and completing the histogram it should look something like this. Then moving on to question 3, it says the table and the histogram show information about the masses in grams of 600 hamsters. And as you can see, we've got some frequency missing from the table, and we've also got a few boxes missing in the histogram, as well as the frequency density axes not being labelled. So first things first, what we need to do is we need to work out what the frequency density is in terms of labelling this graph. So for the first column, which I know a complete set of data, so that's fine. So then what I then need to do is create another column of class width and another column of frequency density. So looking at the class width, that's going to be 30, the next one's going to be 20, the next one is going to be 10, the next one is 20, and the next one is 40. So then working out the frequency density for the first one, I do 120 divided by 30, which gives me an answer of 4. So that means that the frequency density 460 to 90 is 4. So then going back to the graph, I can see that it's two sort of boxes of 5 boxes going up. So if the first one has got a height of 4, then that means that the halfway is going to be 2. So that means that the histogram for the frequency density axis is going up in 2. So that's going to be 6, that's going to be 8, and that's going to be 10. So then from this, I can then work out what the frequency is for the second one by working out the area of the box of the second one. So that's got a width of 20 and a height of 6. So it's going to be 20 times 6, which is 120. And for this one, it's going to be 10 times 10, which is 100. So as you can see now, I've completed the table. So all that's left for me to do is to work out the frequency density of the last two groups. So here we've got 180 divided by 20, which is 9. And that's going to be, let me just fill this in, so that's going to be 10. And that's going to be 6. So in the last one, it's going to be 80 divided by 40, which is 2. So for the next one, I want a height of 4 going from 120 to 140. And that's going to have a height of 9, so that's going to be halfway, and it's going to be, I'm going to do this freehand, but you should be with a ruler, and that's going to be at 9 with a width of 20. That should be straight. And then the last one has got a height of 2 and goes all the way up to 180, so that's going to be look something like this. And again, make sure that your lines are straight and that you are using a ruler. Moving on to question 4, it says that a histogram is drawn to represent the distances in meters athletes threw a javelin in a competition. 3 of the 4 bars are shown. The bar for 85 to 95 is missing. There are 97 athletes in the sample. Complete the histogram. Excuse me, I couldn't get my words out there. Right, so looking at this, what we need to do is we need to work out the area of each of the 3 bars. So for this one, it's going to be 5 times the frequency density, which is 2. So that's 10. So there's 10 people in that group. For this one, it's going to be 10 times 4, which is 40. And for this one, it's going to be 5 times 5, which is 25. So then what I then need to do is take this away from 97. So 97, take away 10, take away 40, take away 25, leaves me with 22. So that means for the last one, I've got a group of 85 to 95. I've got a frequency of 22. The class width is 10. So the frequency density is going to be 22 divided by 10, which is 2.2. So then all that's left for me to do is find 2.2, go across, and again I'm doing this freehand, you should be using a ruler, and then scroll down and shade in if you want to, but it's not necessary. And there is my completed histogram. That's really important that you do show the areas and the frequencies that you've worked out for the 3 bars. You showed that you've taken away from 97 to give you 22, then calculate the frequency density and then simply add it to your histogram. For question 5, it says that a farmer grows pumpkins. The masses of 80 pumpkins are checked. A histogram is drawn to represent the data. The farmer grows 1 million pumpkins each year. Estimate how many pumpkins each year have a mass of less than 4.7 kilograms. So what we need to do first is, out of the 80 pumpkins, we need to calculate how many out of 80 are less than 4.7 kilograms. Now 4.7, looking at the scale, is going to be here. So it's 4 little boxes down, like so here. So what I need to do, and that's 4.7. So what I need to do is work out the areas of this part of the bar and this bar here, because I want the left because it's less than. So looking at the area of that rather poorly shaded yellow rectangle, I've got a width of 0.2, because that width there is 0.2. I've got a height, and I make it out that each little box is going up in 4s, and so that's going to be 152. So if I do 0.2 times 152, I get an answer of 30.4. And if I work out the area of this pink box, which is all of it, it's going to got width of 0.5, and I make out that height to be 32. So it's going to be 0.5 times 32, which is 16. So then that becomes 16 plus 30.4 over the total number of pumpkins, which is 80, and that'll give me the proportion. So that's going to be 16 plus 30.4, which gives me an answer of 46.4. So then if I then do 46.4 divided by 80 multiplied by 1 million, another 0, and that'll tell me how many there are, which there should be 580,000. And there is my final answer. Then moving on to question 6, it says that an animal shelter A weighs a sample of 50 dogs. The table shows information about the masses of the dogs from animal shelter A. It then says that a sample of 50 dogs is taken from animal shelter B. The histogram shows the information about the masses of the dogs from animal shelter B. And it says for medium dogs, which are weighed between 10 and 25, inclusive of 25, animal shelter A has more medium dogs than animal shelter B. Using the table and the histogram, estimate how many more you must show you're working. So looking at the animal shelter A, we're looking for how many dogs are between 10 and 25. So for this, for shelter A, medium dogs is going to be 21 plus 18, which is 39. Then for shelter B, I then need to work out, I draw a line at 10, I draw a line at 25, and what I'm wanting is the area between that region there. So I'm wanting the area of this and the area of this bar here. So working out the area of this bar here, that's going to be 5 multiplied by, and it's 2.6. So 5 times 2.6 gives me an answer of 13. Then if I do the same for the purple, so that's got a class width of 10, multiplied by a height of 0.8, and that gives me an answer of 8. So in shelter B, the medium dogs is going to be 8 plus 13, which is 21. So then working out the difference, it's going to be 39 minus 21, which equals 18 dogs. And there we go. Moving on to question 7, it says the histogram gives information about the ages of members at a gym. And we've got a histogram, and the question's asking work out the estimate for the median age of members at the gym. So what we need to do here is basically work out how many people there are in total, divide that by 2, and then find which group that person's going to be in. So here we're trying to find the median from a histogram. Now, first things first, what we need to do is we need to complete the table. So we need to work out what the frequency is. We then need to work out, now I'm going to add an extra column. So I'm going to have class width, and I'm going to have frequency density. Now the frequency density is just there just to basically, well, it's actually not really needed. To be fair, there is a way of not having to work out these 2 extra columns, but if you wanted to, that's absolutely fine. So the class width is 5, 5, 5, 10 and 20. Then if I work out the frequency density for each of these, it's going to be 2.4, 1.6, 2, 0.8 and 0.6. And again, how I've got those values is just looking at the height of each of those bars and using the scale. Then to work out the frequency, well, the frequency is equal to the class width times the frequency density, or basically it's the area of the bar. So you can either work it out separately. So for example, with this bar here, that's got a height of 2.4. So it's 2.4 times the class width, which is 5. And that's going to give me a frequency of 12. So you could work it out individually, or you could just simply multiply the class width by the frequency density, which is exactly the same thing, but in which I get 12, 8, 10, 8, and 12. Now, looking at the total frequency is 50. So that means that the median person, or the median, median person equals the 25th person. So that's where I want to find where they are. Now, in terms of counting using cumulative values, I've got 12 plus 8. So I need the 5th person in this group. Now, there are 10 people in this group. So I'm looking at this bar here. So let me just get it here. So this block here has got 10 people. And I need the halfway. I need the 5th person. So it's going to be halfway. And half of that class width is 27.5. So that means that the median, therefore, is going to be 27.5. Then moving on to our last question, it says that 40 students completed a cross-country race. The histogram shows information about the times taken, and the question's asking us to work out the estimate for the interquartile range, and you must show your working out. So let me just zoom out so we can see the question all its entirety on the screen. Now for this, what we need to do is we first of all need to work out the area of each of the bars. So we've got 40 students. So let's just write down some facts. So 40 students. The lower quartile is going to be 40 divided by, or times a quarter, which is 10. So it's going to be the 10th person. And the upper quartile is going to be 40 times 3 quarters, which is the 30th person. So I need to find the 30th and the 10th person in this group. So looking at this first column, that's going to have a frequency of 6. This second one is going to be 5 times 1.6, which is 8. This one is going to have 10. This one is going to have 8. And this one is going to have 8. So looking at the 10th person, so I need basically, I've got 6 there and I need the 4th person here. Now, if there's 8 people in there and I need the 4th, it's going to be basically halfway. And halfway between 15 and 20 is 17.5. So the lower quartile is 17.5. Now remember that the quartile values are what you're reading from this horizontal axis. Then to work out the upper quartile, well, that's the 30th person. So I've got 6 plus 8, which is 14, plus 10 is 24, plus 8, which is 32, and so I'm needing 6, the 6th person from this group. Now to find where that 6th person is going to be, what I need to know there's 8 people in that group. So here I need to do the class width, which is 10. Divide that by how many people there are in the group, which is 8. And I multiply that by 6 because that's the person that I need from that group. So here if I then do 10 divided by 8, which is 1.25, multiply that by 6, I get an answer of 7.5. So to find the upper quartile, what I need to do is do 25, which is the start of the group, plus 7.5, which gives me an answer of 32.5. So now I know my lower quartile, I know my upper quartile. To work out the interquartile range, it's going to be 32.5 minus 17.5, which gives me an answer of 15. And there we go.